Just to make sure that everyone is in the right room, we're here for Azure Durable Functions. Yeah? Cool. Everyone is actually awake. That's also good. First session of the day, always a bit of a challenge. For those of you who don't know me, my name is Jaap. I'm a developer advocate at Harness. We are a software delivery company, so we do a lot with CI/CD. So yeah, that's what I use to deploy my my Azure functions. But we're not going to talk about CI/CD that much today. We're going to focus on Azure functions. And just to get an idea for the room, how many people have already created an Azure function? Okay, that's quite a lot of people. How many people have created a durable Azure function? Well, that's still a fair amount. Cool. Yeah, so aside from being here today, I do a fair bit of coding. I've been active in the PowerShell world for a while, and that's also why I figured that Azure Functions, as soon as PowerShell was officially supported, I started playing around with it, finding its limitations, and trying to work with it, and sometimes work against it to get things done. So what we'll be covering today, since not everyone has used Azure Functions or might not be completely familiar, we're going to dive a bit into what Azure Functions are, and from that point on, we'll build up to durable functions. What kind of considerations do we have? What does it look like when we're developing, when we're creating durable functions? How can we create them? What kind of resources do we need? And then we have some example functions with a bit of live coding at the end, and of course a lot of demos. If anyone has a question at any point, just raise your hand or shout out my name. Yeah. So first of all, why would we actually care about Azure Functions? This is my quokka, Roger. I was supposed to bring him along to this trip, but I totally forgot about him. I'm a terrible parent. But the reason I got started with serverless is actually similar to why I became interested in PowerShell and automation. Is because I wanted to care less about the platform that I was working on, and more just about getting the job done. And for some specific tasks, Azure Function is quite a powerful tool. Because my initial way of writing scripts was just to run them either on my local machine or back in the days just spin up a VM in Azure and just have it running 24 hours a day to execute once a day. So very efficient. So we have some benefits there, and that's what serverless provides for us. So we will it abstracts away the servers. It's event driven. So that both means that you can use events to trigger an execution of your Azure function. But it also allows you to scale on demand, and that is something that is a very big benefit. And it's pay as you go, which also has some caveats, because once you start making mistakes in your code, it can become progressively more expensive if you do it with Azure functions compared to just maxing out your VM. So Azure Functions itself, it comes with a whole bunch of supported languages. Of course, .NET is the number one citizen. Most of the best functionality is available. There's also partial functionality in PowerShell durable functions. We don't have access to all the methods there. Node, Java, PowerShell, Python. And it also usually includes batch scripting, but it's no longer there, although you could probably just still hack it together in there. So creating Azure functions themselves. The configuration of Azure functions, if you just look at what you get on your file system, it's just a bunch of JSON files. And then in addition to that, some extra JSON files and a bit of code. The functions themselves, they live inside function apps. So you have an Azure function, the container above that are the function apps. And the function apps, they live within app services in Azure. I mentioned events, so Azure functions trigger based on certain events. So common ones are timer. Another one is just manual, where you just click the button to start it, or an HTTP trigger. HTTP trigger is in general my favorite interaction because it allows you to interact with other API endpoints, and API endpoints can interact with you. So getting into the triggers and bindings. So the triggers I just mentioned. The bindings are also Azure Functions concept. It allows you to define the in and outputs of your functions. It's also more JSON, and here's one of the examples where we bind it to a queue trigger and a table. Then when we get to deploying Azure Functions, we have a number of options available. We can do it through the portal, which is okay to do the first time you're working with Azure Functions. You can use VS Code or just Visual Studio itself. You can use the Azure Cloud Shell or just any kind of command line interface to just use Azure CLI or the Azure PowerShell modules to deploy. You can pull it in from GitHub or other external repositories, upload it as a zip or to CI/CD pipelines. Using pipelines is in general recommended once you start going more towards a production environment. When you're playing around, it's usually a bit overkill to create an entire pipeline. So there's a number of hosting plans available, consumption-based, premium-based, and app service plans. For personal use, the consumption plan is more than enough for most activities. I don't think I've ever been charged for Azure Functions. The one thing to keep in mind is the storage that you use and the application insights. You do get charged for that if you enable that. But other than that, I think it's the first 500 minutes or something in that range. 500 minutes of runtime a month is free. So I alluded to this before. There are some coding practices to keep in mind, and this is language agnostic, but in general just good advice for writing in any kind of serverless functions. So you don't want long-running functions. You want the functions to just have a single purpose. It's not one giant monolithic script like we used to create when we were doing infrastructure management. We want it to be stateless. Idempotency, I'm sure you heard it enough by now because it's been mentioned in almost every talk. So what we mean is, if we execute the function again, we want it to yield exactly the same result. And writing defensively ties back to make sure you don't write functions that will either break and which cause them to fail, or the practice there is make sure that you account for failure, because the only thing that's certain when you're writing any kind of code is that eventually it will fail at some point. And definitely in my case, because my code always fails. The next one, networking. There's some we have some options available there. I haven't run into a lot of issues with the consumption plan in regards to the options that are available. But once you start using them at a enterprise level, it might be nice to put it behind a VPN. So then we'll talk a bit about the limitations that we have. Concurrency is something that we, and these are not limitations of Azure functions themselves, but of the language we use. So concurrency can be a bit challenging in PowerShell. We don't have async statements. If you're familiar with .NET or JS or any of those languages. Accounting for failures is something that we have to keep in mind, and because it is running, it's no longer running on your own hardware. Troubleshooting is also something that you have to reinvent when you're working with Azure functions. And the other thing to keep in mind, if you're on a consumption plan, if you haven't reached out to your function, it can go to a cold state, and then it can take hundreds of milliseconds up to a couple of seconds before it actually becomes available. So that is something to keep in mind when working with Azure functions. So what I'll do now is I'll go into a demo, show a bit of what is possible with Azure functions. But before I dive in there, any questions so far? Yeah.
So I've done a little bit of Azure functions, but I also worked a bit with Azure automation, which
Yep.
kind of runs a little bit in parallel. Do you know the key differences between those two and when you would choose one or the other? Because you run PowerShell and Azure automation as well.
Yeah. I'm actually not entirely sure because there have been recent changes to Azure automation. Yeah. Oh yeah, repeat the question. Thank you. So yeah, the question was, what are the differences between Azure automation and Azure functions? The last time I touched Azure automation, it was still running Windows PowerShell. I'm not sure if it has been migrated over now. Yeah.
The recording on.
Yeah.
We'll do a little funny here. So for Azure Automation is sort of the old granddaddy service. You know, it's been around forever. It runs on Windows, but you can't actually use PowerShell 7 with it now. The main differences are that Azure Automation is really good for those sort of task-based scripts, like, you know, it's your task scheduler in Azure, like for any kind of thing. While you can use webhooks and that kind of thing, it's also really, really good for doing hybrid things. Like if you still have an on-premise architecture, the way that the hybrid stuff works in Azure Automation, if you have stuff you need to run on-premise, you can do that with Azure Functions, but it's a lot more complicated and a lot more expensive. And Azure Automation makes that really simple. Where Azure Functions is really useful is when you have stuff that needs to execute really fast. You want a really nice development environment, because developing for Azure Functions, for Azure Automation, if you've ever tried to do any kind of modules or anything like that, you know, importing it's a real pain. And it just has to do with like some of the legacy stuff that's there. But basically, you know, in short, is Azure Functions is really good for building really nice scalable applications that are survivable and scale out automatically in and out using all the cool input and output bindings, which Jaap will talk about, I'm sure. And Azure Automation is really good for, like I said, for like being that like task scheduler. For when you have those scripts you need to run on a regular basis to do certain tasks or respond to certain things, but you really don't care about how long it takes or where it runs or how survivable it is. That's, in my opinion, the best differences. So
yeah, I agree with that. Thank you very much. But one question: the hybrid workers, are they still going to be around? Because I saw something in my Azure automation recently that they were outdated, but maybe I have old ones.
yeah, I didn't see anything. Maybe the agents are older, but I don't think they're being deprecated, are they?
Deprecation. I think it's the run as. Yeah, it's the
Run as, that's the yeah.
Okay.
So one of the new things in Azure Automation is you can use managed identities now. So the problem with run as accounts is they're basically like an application ID, and by default they get contributor to the entire subscription, which is not great. So now we have managed identities, which are the much better way to do it. They're much more secure. They don't have to have a key that gets rotated. It's just nicer that way. So, you know.
They're also changing the agent out from the old school agent to an Azure Arc-based agent. Yeah, that's the other thing that's changing now.
Okay, cool.
They changed the way how we install it from the agent base to extend.
Sweet. It's always great to have the actual experts in the audience. Thank you. Any other questions? Otherwise, we'll go take a look at some Azure functions and just the basics, what it looks like. Sweet. All right. So we'll go take a look in the Azure portal. I'll make it a bit bigger. I'll verify myself, see if it's big enough. So what we have here is an HTTP trigger. That's not really big enough yet. That's an HTTP trigger. And the goal of this function is to just return an SFG file to have some automatically generated images for the website. I got started with that when I saw the cool tokens, the cool counters, the visitor counters you could have on your GitHub profile, but it was running on a free service, so it didn't work half of the time. So then I made my own on Azure Functions, and this one is part of that system. So all it does is it injects whatever we tell, whatever string we put in there, it will create an image out of it. So we can see here, so now it returns Jaap and PowerShell. It's also very good that I share my key on screen. So we'll change it to bell. So we can see if we run it again. Are we connected to the internet? Yes. Come on. There we go. You can see that the image updates. You can also change the color on this one based on the color variable. So that's just hexadecimal. Don't know the colors by hand, but we can see that we can update it like this. So this is just a short function. We'll take a look at what it looks like from the code point of view. So we can see here it has some right hosts. We have a parameter block where we have the request and the metadata. We split this one up so we can get first, second, and color, assuming they are available, and then we inject that with string formatting to put the words and the color coding into the SFG file. So it's pretty simple. And what we can do from the portal as well, we can also specify the response here. But the downside of that is that we won't be able to see the image because wrong button. That's the downside of being zoomed in. Oh, I'll get back over there. And if we click here, we give it a second. In the portal, usually the things stay grayed out for a little bit before they realize that they should actually not be grayed out. Come on. Oh, there we go. Sweet. And then the next thing is that if we want to see what it looks like here, we can do code and test. And we'll also connect to the logging interface, and we can actually see what happens when the code gets executed, and it provides a bit of basic troubleshooting. Come on, conference Wi-Fi. I'll leave this one for what it is then. So going back into our function app itself, you can see that inside the function apps, we can choose the function apps that we want. So I select the PowerShell one. As I mentioned before, our functions are stored in here as soon as it shows them. You can see we have multiple there. From a configuration point of view, available here as well, also in code. So what is important to note about this specific function app is that I completely deployed it to the portal. That's why I'm able to also change the code in the portal. That's an okay thing to do when you're doing a demo, but in general, when you want to be deploying your Azure functions, my go-to way is to do it through VS Code and just deploy directly from VS Code. And how that works is it just uploads the functions as packages, and then they're no longer able to be changed in the portal. Yep, so we can see a couple of things here. We can see our function runtime version. So we're currently on version 3. So I've been getting a lot of banners that I should upgrade this one to 4. For Azure durable functions, we need to be on runtime level 4. The last one we have is we're going to take a look at this function. Here we go. So we have another one. This one will return some nice ASCII art. And while this one's loading, I'll actually execute the code. So I'll just call it directly from PowerShell. There we go. So we can see we can just use invoke REST method with PowerShell to get output from our function, and we get a nice cat in the console. Not very useful, but I do like a bit of art in my console. So if we take a look at our monitoring, we have a couple of options there as well. And that one's too slow. I'm not going to be waiting for that one. Cool. So with that out of the way, any questions about Azure functions themselves? All clear? That's fantastic. So let's get into the real meat of it then, the durable functions. Yeah, I already asked people who is already used durable functions. There were a couple of people on this side of the room. What are you currently using durable functions for? Is it just experimentation? Whoever, okay, some people experimentation. Yes?
Actually, what is the definition of durable Azure function?
Good question. So a durable Azure function, that's also what we're going to get into now. A durable function is I think I'll just go to my slides and then build up build up to it. But the idea is that instead of just having your the situation you're in, if you're just using Azure functions, is you can have an Azure function that calls another Azure function that calls another one, and that are all interacting with each other. But if one of them fails, there's no system in place to make sure that either it gets executed again, there's no error handling that you have on the scale of interactions between your functions. And what durable functions provides for you is it provides an orchestration layer. So you have a number of different durable functions, and that are these. So we have client functions. So client functions is what you would directly interact with. So this could be your HTTP trigger in order to start your orchestrator function. Your orchestrator function is basically your script that will detail how the functions are called. You can put your error handling in there, and what determines what type of durable function you're creating, because there's different ways that you can go and different sort of deployments. There's also entity functions. Entity functions are, I'm not sure if it's exclusive to .NET. It is definitely available in .NET, but it's not available for PowerShell. But I mentioned that they exist because they do exist. And the activity functions, that is what the Azure functions were that I showed before. So the cat function, that would be an activity function, or any kind of function that is called by the orchestrator. Those would be your activity functions. So the question was, what is the difference between Azure functions and Azure durable functions for the recording? Does that answer your question?
Yeah, I think so.
Sweet. Anyone else? Okay. So orchestrator functions have a number of actions that they can take. So they can execute the activity functions. There's the possibility for sub-orchestration. So if you're starting to build out more complex situations in which you use durable functions, you can work with sub-orchestrations, not available for PowerShell durable functions. You can have it wait for external events. It can do HTTP requests. Timers can be in there. There's a number of constraints as well. So some of the constraints that we have with orchestrator functions is things have to be deterministic, and the reason for that is that what the orchestration function does for you, if one of your functions fails, or an execution fails, or one of the nodes on which your activity, so your Azure function within the durable function was running, crashes for some reason, it will try to restart the job with the same kind of parameters. And if you have non-deterministic values within your orchestration function, it will not play nice, and it will get you into situations where the orchestrator does things that are quite unexpected. So what it means for us is there's a bunch of wrapper functions available. So for example, with getDate, you would use context current date, and there's wrapper functions for all the different languages as well. That's one of the PowerShell examples. Also, in a similar vein, no random data. So if you want to generate GUIDs or UUIDs or any kind of randomness, you can move that towards your activity functions instead of inside of your orchestration. Is that all clear? Sweet. The last one is infinite loops. Also a bad idea. Can be a good idea depending what you what you're trying to achieve. But infinite loops in some scenarios means infinite money, but unfortunately not infinite money for us, but infinite money for Microsoft. So try to avoid accidental infinite loops. One of the scenarios that I had was that I didn't realize that an object was referring back to itself when I kept iterating through all the properties of an object. One of the properties referred back to the object, so it would keep on going and keep on going and keep on going. Sorry? Context? No, it was not the context property. It was, what was I doing again? I think I was working with Outlook mailboxes, and there was one property that referred back to the mailbox itself. So then I thought I discovered a new mailbox, but it was the same one again, and then it would iterate over it again. And the nice thing about it was that for every mailbox, for every single email, I would spawn a new process. So there were a lot of processes spawning. And then all of a sudden, everything started timing out because Azure functions can scale quite well, but if you push it to the limit and you start having millions of executions simultaneously, you're going to get throttled. Because the moment you start bringing down a data center, that is of course not not what anyone wants, let alone Microsoft. So then we have a number of patterns that we can create. So the patterns that I'm talking about are the patterns as you can set it up in your orchestration durable function. So we have function chaining. This is this was actually the first use case for which I started using durable functions, because I had a number of functions that were feeding into each other. And I also had failures within those functions. And I tried to create the logic within each individual function to deal with the next one failing. But after a while, that's not very maintainable, because you end up with an enormous amount of boilerplate code in your functions, and it goes against use less code in your functions. So this one is quite useful in situations where like your first function outputs the data, the second function picks it up based on the queue trigger or storage trigger. Second function fails. What the orchestrator would do is it will take the state that all the functions were in. It will restart function number 2, get the data out again, and push it onto function 3. So that is what durable functions provide for us. Next one is fan out, fan in. That's a situation that I just described, where I was iterating to mailboxes and to users. That's a big benefit of Azure functions and serverless in general, is because you can so easily scale outwards with durable functions, but with serverless in general. Kind of lost. So it allows you to rapidly scale out and then put a hold on, depending how you create it, either wait for all the output to be there, or start inputting the output into the follow-up function. So this is quite useful for situations where you might need to work with huge amounts of data. So if you're thinking about migrations or extracting a lot of data out of a tenant or subscription, and you would want to apply it somewhere else, the fan in, fan out model is quite useful. The demos later on, these are the two that we'll mostly go into. For my personal use cases, those are the most common one. Next one we have is asynchronous functions. So these are generally used for longer running functions. An example for this one is we all use OneDrive, right? Or we at least are familiar with what OneDrive is. So if you're on OneDrive and you click, you select 2 files and you click download, it takes a second before it says there's a download link now. So that is done using an asynchronous function. Or you could achieve the same thing with an asynchronous function. Then we also have a monitoring function. Monitoring function, it's the wrong image, this human interaction image. But a monitor function is just a function that monitors the output and takes action based on that. Then we have the human interaction. So that's for approval flows, for example. Not something that I've gone into a whole amount. In general, in these kind of cases where I have approval workflows, I think Power Automate is a very powerful tool for those kind of interactions. So I haven't really found a specific use case to apply with Azure functions. And then the last one, the biggest one, that is the aggregator, and that is when you're ingesting big amounts of data into your Azure functions. So, any questions about the different patterns here? Alrighty. Yeah.
Where's a good resource to learn about these patterns or potentially other patterns?
Yeah. So there's a couple of resources. So switch ahead to one of the slides that I have here. There's Azure Functions University. That's a general good resource to learn about Azure Functions, including durable functions with all the different language models. There's function samples available in docs.microsoft. If you search for durable functions samples, you'll end up there, and those are both on GitHub and on the Microsoft Docs. And the question was, what's a good resource for learning more about the different patterns? And the nice thing is that there's samples. Sorry? Yes. So the question is, do you have any kind of control over how much you scale out? Yes, you do. That is what you define in your orchestrator function. So your orchestrator function is just a PowerShell script. So it is, however, you would normally control it when you're writing a script. That's exactly the same ability you have with durable functions. And that can indeed be a smart thing to do, because then you don't end up in a situation like me where your entire tenant gets throttled because you might not have done the smartest thing. Does it answer your question? Sweet. Cool. Well, then we'll go take a look at what it takes to get started with Azure durable functions through the magic of demos. And for everyone here, if you have a question during the demo, I'll probably be looking at my screen, so I won't be able to see your hand. Just shout my name, or if you see someone else raise their hand, then also shout my name. Thank you. And let's see. Cool. So the first thing we'll do is we'll take a look at what we've set up in VS Code in order to get started with Azure functions, Azure durable functions specifically. Yeah. How's that? Yeah. So getting started with durable functions, obviously we need to create a function app in order to be able to deploy our functions too. One of the recommendations is also to create a storage account specifically for your durable functions. It will be used for storing all kinds of runtime logging information on there. it will automatically prompt you the moment you start a durable function project. So getting started with a durable function is Azure Functions. So what we would do here is we would create a new project, and that is what we are currently in. This is our project that I created. So we have three functions created. So we have our starter function for the chaining. So the chaining was this approach where we chain multiple functions into each other. So we have our starter function. We'll take a look at what is configured here and what is different compared to regular Azure functions. So we can see that there's a number of durable commands in there that are specific to Azure durable functions. So our starter function is, this is just the boilerplate version of it. We pass in the name of whichever function we want to execute. So we do it by specifying the function name, and then it will start our orchestration for us. So in our case, in the function chaining example, you can see here, that one on the side, you can see here that a very simple example of this is we just get all the output, and we get the output from a single function. The function is called getterData, and it will input. It will give this as input to gather the data. Our function itself does not actually gather any data. All it does is it will just spit out whatever you put in there. But it's just to illustrate what would happen if you would set this up as an orchestrated function. So then, after we create these functions, we have the option to deploy it to a function app. So currently it's already deployed. But we can see that we have a durable chaining demo, and that's where we will go take a look at now and see what it looks like, what a durable function looks like in the Azure portal, and how we can execute it. There we go. And before I go into the durable function itself, what we'll do here is, I mentioned that there was a storage account that will be created the moment you get started. And if you take a look here, we can see that the moment you start working with your functions, it creates a number of queues and tables with all the data in there. So if we take a look here, we can see that all the functions that we had on our system, in VS Code, I mean, are also available here. Pull up code next to it. There we go. So in order to be able to start our function, we would do an HTTP request to this one, our starter function. So we can see now that we also get a warning because we didn't deploy it to the portal, we deployed it to VS Code. So you can see that we can't actually make any changes here, which is
locked in based on your version of how you deploy it.
Yes, it's similar if you're deploying your. You can also put all of this configuration directly on GitHub, and then the moment you can set it up to a GitHub action. The moment you do a new commit to whichever branch you specify, it will automatically package everything up and import it as a new into the function app. And that's essentially what VS Code is also doing for us. Everything we see over here on the side, it will package it up and put it into the function app so we can work with it. So the main difference here is that if we go to code and test, we won't be able to make changes here. But on the other hand, you don't really want to be coding in this interface because it isn't fantastic. We can take a look at it though. So now if we wanted to run this, we can go for test run. We can enter our chaining function name, and then we would be able to execute the function. So then if we go, let's see, yeah, we would go to the orchestration here. You can see we haven't had any executions in the past hour. So let's take a look at how this is set up. So you can see our trigger here is the orchestration context and the orchestration chaining. So now if we would like to go for some additional functions, and we want to, for example, go for fan in, fan out, cancel this one. We'll create some new durable functions now to give you an idea of what it looks like if you want to create your own functions from scratch. So we can create a new function. So we can see here, create Azure function. Unfortunately, that is not the correct one that we need. So we can do create dur. That is create function. And then we have an option for the HTTP starter or the durable functions orchestrator. So in this case, we already have the HTTP starter because we can reuse the starter chaining because we didn't hard code any value in there. So what we'll do is we'll get started with an orchestrator, and then we'll go for this approach. So we're going to fan out and fan back in, and see what we can do with that. So we call this fan out, fan in. So currently it is not an fan in, fan out approach yet. I'll just take some of the action from this one. So then what we do here, let's get it all on screen. So we have our parameter block for the context. In this case, we have the parallel tasks here. So we can see, I just do a simple 1 to 10. Then I wanted to call a function. So we haven't created the activity function yet, but we will call it fan out, fan in, gather. And as the input for that, in this case, we'll just use 1 to 10, because I know that for the purpose of this demo, I'll be using these values will actually give us some data. So we can see we do invoke durable activity, and for the output, we would wait for all the parallel tasks to be completed. So at the moment, we don't have any kind of concurrency control. So if we would do 1,000, it would simultaneously fire off 1,000 Azure functions. So if you're in the development part of your journey, probably don't start with the biggest number possible. And for fan in, we're actually not fanning in. We're just verifying how many results we have and give us that as output. So this is fan out. So now that we have this one, we also want, yes.
How can you tell how many are currently running so you don't start more than a certain number of?
That's a good question. I think. So the question was, how can we actually implement concurrency control? Yes. So for the recording, nothing built in as far as we know, but we can inspect the queues and see what is concurrently running. Was there a question? Cool. All right. So we have our orchestrator function. So next up, we're going to create our next function, our activity function, to actually get something out there. So we create a new function and see that there's a lot of options available, but we'll go for an activity. So our activity functions are our workers. In this case, get Pokemon, and the reason it's called get Pokemon is because we have an API endpoint that we can make a little bit bigger. And what we have here is that we can use those numbers that we have to illustrate what would happen if we would iterate through that. So the number 1 will actually refer to an existing Pokemon, and we'll use this as a mock example to see what is possible with data collection using the fan out approach. So we have our URL here. So we'll update this. We'll update our worker function with an ID, and we'll use invoke REST methods. So bonus question: why would you use invoke REST method over invoke web request? Anyone? Yeah. Yeah, that's correct. And in general, invoke web request also has a bit more overhead because it tries to parse the data more. Yeah. Okay, so the question is the context, if you make changes to the context in one of the child activities, does that flow back up as?
I guess another way to say it is like, is that context, is it a global scope or is it a script scope?
So as far as I've experienced it, it's the child scope does not make changes to the parent scope. So any changes you make in that scope are just within that activity function or whatever the function is. But if anyone can correct me there. Mm-hmm.
Hello again, guest speaker here, Justin. So the thing you want to know about the context object is it's dynamic for depending on what, it's basically the collection of what your input bindings are. So dynamic, the whole way that durable functions work is they take a lot of the input-output binding stuff that you would typically do and then just hide it all from you under the scenes. So really what it's doing is behind the scenes, it's getting an input binding from a queue or a blob when you do like your push, and then it'll, under the scenes, like drop that into a queue, which then connects to your other function. That's why all these commands have to be kind of stateless, is because it's just running the same script over, but there's no state that carries over. So to shortly answer your question, that context is basically just when you get it, if you change anything in there, it's only going to live for the lifetime of that script, unless you do something like a push output binding to drop that somewhere so that the next time the script runs, again, it's a fresh instance, and it's only depending on what it gets from those input bindings, which is just dynamically done for you with the durable function. At that time, then, you know, if you were to push to change something that way, then that will show up in the next execution. But as far as the context object itself, if you do like, yeah, like if it's like $context.myParameter, if you change that to like myParameter equals something else, that's not going to carry through the next function. It will for your current invocation, but like the next thing that picks that up, it's the context is going to be whatever it is based on the durable function. So does that make sense? Okay, sorry.
Yep. No. So the question is, is there any kind of global variable that is passed down? Anything that you pass into a function to parameters, that is going to be available in that function. But anything else from the parent scope, they're completely in isolation of each other. They might happen to run on the same machine, but the next interaction might be like it was mentioned, another data center, another host, maybe even a different operating system or a different version of PowerShell wouldn't happen. But cool. So let's get that output out of there. So we have our URI, so we can enter in our ID, make it an expanding string, and now we have the basic for a fan out approach here. So what we can do by going back into our orchestration function, we can see here that let's make this one. Oh, no. That was the wrong hotkey. Okay, I just broke it. And let's copy it back. There we go. Sweet. So what we can do here is we can also make sure that there's some kind of error handling here. So we could put try catch blocks in there if an activity would fail, or a number of switch statements to have some kind of flow control, so we can take into account that a query might fail, or you might have overloaded an API endpoint by sending too many requests. Those are things that you would take into account inside of your orchestration function. Cool. Then going a bit further. So currently, what we have is we take our array. Our array is just 1 to 10. We execute it. We gather all this data. The next step can be to gather more data. So this activity could also we could also create a different activity. So let's take a look at the API endpoint and see what kind of things we can query. Other than that, we can get some kind of information out of it. So let's go for item. I used to always do this with the Star Wars with the Star Wars API, but the movies have really been terrible lately. So Pokemon it is now. We'll go for type. So what we'll do now is we'll just pretend that we're gathering more information. Well, we are actually gathering more information about these Pokemon. So we create another function. So this will be another activity. And that is the activity, yes. Fan out, fan in. Get item it was, no type. Sweet. So once again, we'll change it to ID. We have the URL there, and we can just use this one. And we can go into our activity function and make sure that we get all the output that we want out of this. Let's see. So we have the ID here again. And yep, so we wait for all the outputs. We already mentioned how many, so total amount of Pokemon. The next thing we can do is for outputs, and just throw that in a for each block. And we can do types. And then we take the get type. This one is the get type. And we should also update this one so it actually goes to the correct one. So one is get Pokemon. Sweet. So then we need to make sure that we actually get this one. So we're going to wait for all the async tasks to output again. We know that it's going to be 10 at the same time because we just gathered 10 objects, or I suppose maximum 10 objects that we're going to get out of this. And this one is output types. And then we have our functions created. So we have two options now when we're developing our functions. So we can either choose to run it locally, or we can push it to Azure. If we want to run it locally, we can run it from here, or we can choose to deploy it up to Azure. Yep. So we'll give it a second, then it will come up with our function app. Yeah. It will emulate the storage here. It will emulate the storage, and I used to have more issues with this in the past because obviously this MacBook, and I ran into issues with debugging Azure functions, but these demos have not failed locally yet, but I'm still not chancing it because it has disappointed me too many times, so I'm just going to push it to Azure. Yep, so you need Azure Functions. Some of the requirements are you need the Azure Functions extension in there. There's nothing specific to durable functions, it's just integrated in there. You need the Azure extension as well, so you need to be logged into Azure. I can show you that. Let's first push this while I talk. So what I'll do, there we go. Get a nice notification if I really want to deploy straight to production. But we always, it's not even Friday 5 p.m. So we can see here that we are deploying, and in our output window we can follow what is happening here. Yeah, as I was saying, deploying into Azure, you need the Azure extension as well. Aside from that, you also need the Azure Function CLI on your system, and that was part of the issues that I was having on my MacBook previously. Is it had installed it to Brew and to npm, and then it got upset because there were two versions and it didn't know what to do. I also got upset. Yep, so we're pushing it up now. So in the meantime, I'll go over to our browser, see if we can see them show up. You can see that they're up there. I'm not sure if the deployment is completely complete. You can see that the triggers are set to as activities and as orchestration. And if we want to execute it now, we can either go into the starter function and type in the function name. And the function name we want to execute is going to be the orchestrator, not the other functions. One of the things to keep in mind of the orchestrator is that it should always be triggered to the activity function. You can the activity, the words, the starter function. But you can individually execute your activity function. So if you want to do some testing with your activities, they are as close to a regular Azure function as it comes in Azure durable functions. Yeah. So what happens if we execute it? The orchestrator will start up. It will check the state of the execution, because the orchestrator doesn't know if it's the first time it's being started or that it's being called up to take the next step. So it will always take a look at the execution history and base its actions from there to what it will actually execute. Yeah. Then the last part of this one, so we can see that it also gives us the URLs, so we don't have to look that up anywhere else. And make this one a bit smaller. Yeah, the one thing I need to show on here, then I do the rest in VS Code. For deployment, currently everything is just deploy to master, deploy to production. But you can also configure the different deployment slots, which is probably a good idea if you're using your Azure functions for anything more critical than just showing a cat photo or gathering Pokemon. So you can see this one goes to production. You can choose your deployment slots here and your deployment strategy based on that. So if we want to take a look at some of our Azure environment. So if you have the Azure plugin installed in your VS Code, this is where you can also choose to create a new function app and use that as the deployment target. So if we want to do that, we can go here and we get an option to create either a function app or a resource group, but we can create any kind of resource here. Alternatively, you could also use the CLI or a PowerShell command to create a function app, or use an ARM template, or use Bicep, whatever your jam is. And one important thing that I missed out on so far is another critical extension is going to be VS Code Pets. That is definitely mandatory whenever you're developing this, and if you're waiting for the deployment to actually be pushed to Azure or anything like that, this one is, I just like it. Can get Clippy in there. It's my favorite extension. Actually, the person that developed a lot of that made the images for a lot of those pets is also the same guy that runs or that started the Azure Functions University on GitHub. Great resource. Cool. So the additional resources, I already mentioned that part. Azure Functions University, it's a GitHub repository. It has training materials for both durable functions and regular Azure functions. And it's basically a a tutorial, like you get a goal, go to these steps, and you'll get started. The samples on GitHub from the Azure team itself are sometimes a bit outdated, so be careful to check how long ago the last commit was to a repository, because otherwise you might be working with old code or code that was intended for an earlier version of durable functions. The Microsoft Docs are a great resource as well. And I realize that I'm 15 minutes early, but at least we have plenty of time for questions. Yeah. So the question is, you can use the fan in, fan out for abusive purposes as well. And are you mostly concerned about your APIs being abused, or your function? Well, one of the things that we chose not to do is here we have the no wait parameter, so we can also make it wait. So then it's just one at a time. Then it's already less abusive. So yeah, to rephrase to repeat the question was: is there any way that we can be sure that we don't just blast and or give an API endpoint the hug of death because we are fanning out so big? We can change the, oh, that's why we don't see anything. Here we go. So we can change the parameter to actually wait. As for your own API and your own function endpoints, you can put it behind an API management tool. Azure has some. There's a lot of third-party tools that can help you with making sure that you don't get DDoSed or you don't get charged an insane amount for a lot of pointless executions. Yeah. Yeah. So the question is is there a runtime limit? In one of the Azure functions slides, so before we got to durable functions, I mentioned that it is supposed to be short running functions. So it's between 5 and 10 minutes. There's ways you can work around it if you want to have longer execution times, but it is not recommended. If you're in a situation where you have to wait that long, try to do things asynchronously. Try to have a function call itself after a while, so it doesn't kill itself, or take care of it through the orchestrator, or use a different tool, because in general, serverless, not just Azure functions, is not intended to be used for long running tasks. Then Azure automation might be a better tool if you have those really long running tasks. So the addition from from my co-speaker Justin was that if you have a premium plan, so not the pay-as-you-go, then you have more options in regards to how long you can run it, because you get your own instance. Additional benefit is also that your instances can be beefier than the regular ones. I think it was double CPU, double memory for the nodes. Yeah. No, this does not. So the question is, does this need to be quoted within a string? No, it doesn't have to be, unless there's spaces in there. Then you'll have to escape it otherwise, because it will think it's multiple parameters. So you don't have to put it in strings. But I do put it in strings, because otherwise I'm going to run into a case that I'm not even sure if you can put spaces in function names. I never tried. I wouldn't expect so either, but let's find out. Yeah, no. Yeah, all right then. Well, in that case, let's go back to the slide. If any other questions come up, I'm on Twitter. You can reach out to me there. I'm happy to help out. Thank you for your time and for showing up this early. Have a great conference.